Welcome to another futures video. At the end of the last video, I had made the observation that in the regression equation, delta CP equaling beta naught plus beta 1 delta FP, that beta 1 was, of course, the change in the cash price associated with the given change in the futures price. Okay, and also I wanted to note that beta is going to, of course, be equal to the covariance of delta CP delta FP divided by the variance of delta futures price. Both these are true. Okay, and so let's continue. I now want to show you some application of portfolio theory to this idea of hedging. And let's start by making the observation that we've done many times before. The variance of the return on this portfolio of two securities is equal to the variance of the spot asset plus the hedge ratio, call it HR squared, times the variance of the futures price, plus 2 times the hedge ratio times what precedes this, which is an unseen 1. So 2 times HR times 1 times the covar of the cash price and the futures price. Okay, this HR square term, okay, is a constant that is squared as it should be in this decomposition of portfolio return variance formula. Okay, so that's just like where we used to see the variance of AX plus BY, and we would end up with an A square var X term and a whole bunch of other stuff, and that's the same thing that's going on there with the HR square term. Same phenomena going on there. Okay, so let's now work with this a bit. Okay, so we basically have 1 unit of the cash asset and HR units of the futures contract. Okay, and now I'm going to plug in the correlation term for the covar. So that will leave us with the variance of the cash price plus hedge ratio squared times the variance of the futures price plus 2 times the hedge ratio times the correlation coefficient between the cash price and the futures price. So C comma F. And then that's multiplied by, of course, the standard deviation of C times the standard deviation of the futures price. Okay, so that's where we are. Now, in order to minimize the variance, okay, then what we want to do is we want to differentiate the variance of the return on the portfolio with respect to the hedge ratio. Okay, and when we do that, this term right here, focusing on that for a second, becomes 2HR to the first power times the variance of F. Treat var F as a constant. Okay. The we noticed that this first term, of course, didn't have an HR in it, so it was not relevant. Now the second term does have, the third term does have an HR term in it, and since we're differentiating with respect to HR, then that's going to leave us with plus 2 times the correlation coefficient between C and F, and then multiplied by, and I use the other notation, sigma C, sigma F, because I ran out of room there. Okay, so we're left with that. Now, in order to minimize the variance, we want this to equal 0, right? So we're now going to set this, which is equal to this, equal to 0. So again, derivative of variance return on a portfolio with respect to HR, we're going to set it equal to 0. Okay. When we do that, well, let's bring the term with the HR, which is this term, I'm having trouble with my pencil here. Hold on a second. There we go. That term becomes, that term we're going to move to the left-hand side. So we will have 2 HR var F 2 times HR times var F is equal to, well, since this term is moving to the other side, it becomes minus 2 times, I'll now use the other notation for correlation coefficient, rho CF times sigma C times sigma F. Okay, so we have this. Divide both sides by 2, of course, gives us HR times sigma square F. Again, just using the simpler notation, equals negative, divided by 2 again, negative correlation coefficient CF times sigma C times sigma F. And then next step is to divide both sides by this term right here. Okay, so then we're left with hedge ratio equals negative rho cash correlation coefficient between cash and futures price times standard deviation of cash price times standard deviation of futures price divided by sigma square F, the variance of the futures price. And then I'm going to kind of reverse my earlier substitution. I'm going to recognize that that term, of course, is equal to the covar between C and F, cash price and futures price. Trying to get the eraser to work here. And it's not working. So, just saying that this is covar. Okay, and so our next line will be negative covariance between the cash price and the futures price divided by the variance of the futures price. And so right there, is what I'll now call HR star, okay? Because that is the value for the hedge ratio that is going to minimize the portfolio return variance, right? Because we took the derivative with respect to HR, the hedge ratio. Okay, so that's an interesting outcome. And once again, we see the importance of covariance. Here we're applying portfolio theory to our portfolio involving a spot asset and a hedging position in a futures contract. And so, okay, so that point's been made. Let's move on. And next we have an example. I'll tell you what, I think I'll have that example be a separate video. That's all for this video. Thank you for watching.